Okay, in the previous lecture, we started the topic of travel demand modeling or forecasting of travel demand, and we discussed some basic concepts related to it. And basically, it can be divided into two categories: urban travel demand and intercity travel demand. Uh, the factors which can influence the travel demand include the land use and the location, the socioeconomic factors, and the characteristics of the transportation services. And then these are the steps which are involved in the forecasting of travel demand uh, to find out the land use and travel characteristics. And then these are the four stages of travel demand modeling. And we were discussing the first stage, which is trip generation. And in trip generation, we are basically trying to find out how many trips will be generated from each traffic analysis zone. And there are three methods to do it: cross classification, rates based on activity units, and the regression analysis. And we were looking at an example of cross classification method where uh, the trips were calculated on the basis of household income and number of cars per household. So we completed one example where data was given for 20 households from a region, and trips and household income and number of autos per household was given for these 20 households. So using that data, first of all, we developed the relationship between, or we developed the metrics between number of cars in the household and income. Okay, and basically we are trying to find out what percentage of household we have in each category. So how many people have low income and zero cars, how many have one car and two car. So basically we're trying to find out in this matrix from the available data how many households from each category. Then the second relationship or the second matrix was for number of trips. Okay, so number of trips belonging to each category of income and number of cars owned. And for each case, we made some graphs as well. Okay, so 24 people having less than 24,000 or equal to 24,000 income with zero cars on average had 3 trips. Those having one car on average had 5 trips, and so on and so forth. So we found the average number of trips for each category of cars owned and income. And the third step, which required additional origin destination data to be taken, and in that data we found the number of trips for each type on the basis of income. So how many trips were taken from home to somewhere else, how many trips were generated from facilities which were not homes, and how many trips were taken from home to work. Okay, so percentage of trips, origin destination data, which included only the income and the type of trip taken by that person. Okay, so on the basis of that, they developed this graph as well. Now, this is an extra or additional extension. What can I say? This is an extension of the previous example. So in the previous example, we have found the percentage of households belonging to each income category and each car ownership category. And then we found average number of trips from each category. And then we found percentage of trips, home-based and non-home-based trips for each income category. This is what we have done. And now we are going to use that data in this example to find out the number of trips for the entire zone. Now the data from the zone from which that data was taken has total 60 households. Total number of houses in that zone is 60. Out of 60, we took 20. Okay, and usually the number is the proportion of data taken and the actual number of households is very low. Okay, here 60 and we have taken 20. This is 33% collection of data. Normally it is not more than 5-10%. Okay, so they are showing us a very optimistic figure. Okay, and for that zone, from government figures, from some other data, they found that the average income for these households is $44,000. Okay, per household income is $44,000. This is coming from the overall data of the government. Okay, how many households and the income. Now, using that data and the relationships which we developed in the previous example, they want us to find out a number of trips per day generated from the zone for each purpose. Purpose means these things. These are three main purposes. Trip taken from house to somewhere else, trip taken from house to work, and trip which does not start from house. Three main categories. Okay, you can further subdivide it, but these are three main categories. If you observe for your term project, I have just restricted you to trips going to work. Work or study means the same thing. Okay. First of all, out of these 60 households, find out the percentage belonging to each income category, and again that will come from census data. Okay, the percentage of households belonging to each income category, that will come from the census data. Now this is what we developed from the sample data, the 20 household data. These curves are developed from there. Okay, so according to census, 9% households belong to low income category, 40% household belong to medium income category, and 51%, the remaining 51% belong to high income category. Okay, and if you plot these three over here in this graph, the graph which we have developed for the 20 households, the average it's already given $44,000. Okay, so if you draw a line from $44,000, that line should intersect the line showing the three income categories at these points. So on the y-axis we had the percentage of household. Okay, so if you draw a line from the 44,000, what is 44,000? The average income of the entire area that is given. Okay, and from the sample we have already plotted this curve, these three curves. Okay, percentage of household belonging to each income category. Okay, so we have one curve for low income, one for high income, one for medium income. Okay, these curves are already plotted. Okay, these curves are plotted between income and percentage of household from the sample data. Okay, so how many people had this much income in the sample? This much percentage. This is around maybe 60-70%, I don't know. Okay, and how many people had this much income? Okay, and this much percentage. Okay, so this entire line goes from 0 to 32,000. This line goes from 32,000 to 48,000, and this line, goes above 48,000. Okay, so from 44,000, which is the average income, if you draw a line, a perpendicular line, which intersects the three income categories, the point at which the line will intersect the income lines will give you the percentage of household belonging to each category in your data. So from 44,000, if I draw a line, and the line intersects the low income category at this point. Okay, and this point shows a percentage of 9%. Okay, then you extend the line towards medium income, and the percentage you get is 40%. Then you extend the line towards high income, and the percentage you get is 51%. Okay, so these are the percentage of households in the entire population. How did I get it? I drew a line from the average income category. The average income was given from the census data. Okay, or if you directly have these values, fine, then you don't have to do this. Okay, then you don't have to do this, but many a times only average income is known. Then from the sample you draw these curves, and then you draw a line from the average income category, and the point where the line intersects the three income categories, that will be the percentage of households for each category. Okay, this is step 1. Find out the percentage of households belonging to each income category, which is this much. Okay, then find out the distribution of car ownership per household for each income category. You know, how many household have, for example, you know, one car, and how many household for each income category has 2 cars, and so on and so forth. Okay, and again, this curve is already plotted from the sample data. This curve is already plotted from the sample data. For example, you come to medium income category and 1 household line. Medium income category and 1 household line. Okay, so you find the percentage of households which belong to medium income category, okay, and have 1 car is 58%. The percentage of household which belong to medium income category and has 1 car is 58%. Okay, and from the total okay, sorry for that. From the total, how many households are having medium income? For example, from here we know 40% households have medium income. Okay, so out of 60 households, 40% have medium income. And out of the households which are medium income, how many have 1 car? That is 58%. Okay, and this is basically coming from the curves which we have plotted in the first example. The curve which we have plotted in the first example. Okay, so these curves are already plotted. So for example, I go to medium income line, and then I go to 1 auto curve, and I find out the percentage. Similarly, I go to low income line, okay, and then I go to 1 auto category and find out the percentage. The percentage is 54. Okay, so low 54% is for 1 car, okay, and medium 1 car 58%. Okay, and this is the line for 0. So if you go from low income to 0 car category, you find 54%. So 54% household having low income and 0 cars. Okay, so if you want to calculate how many households for each income category and car ownership you have to have these curves. Okay, and then from these curves you draw the line from each income category and then towards the curve for your auto ownership, and then you go towards the y-axis and find out the percentage. Okay, so and to find out the actual number of households for each income category and car ownership, you divide the total number, multiply by the percentage of household for that income category, multiply by the number of household, the percentage of household which has that income category and the car ownership which you are looking for. Okay, so 38 plus 58 plus 38 will be how much? 38 plus 58 is 46 plus how much will it be? 96, right? 96 and plus 4. So for each category you will have like 100%. Okay, so out of medium income category, 4% is having no cars, 58% has 1 car, and 38% has 2 cars. Okay, and if you multiply this percentage with the percentage of households of that income category in the area and multiply with the total number of households, you will get the number of households belonging to each cell in this matrix. Okay, so So if I go back, let me go back. First example. Okay, so these are the curves we plotted from this data. Okay, so from this data, we had the three income categories: less than 32, 32 and 48, and more than 48. Okay, so first of all, I separated the household which have 32 or less than 32,000 cars. Okay, so how many are these which have 32 or less than 32? 1, 2, 3, 4, 5, 6, and 7. Okay, then from these 7, I will find out the percentage which have 0 cars. So according to the table which I showed you, there should be 54%. Okay, out of these 7 which have low income, how many have 0 cars? 54%. How many have 1 car? 42%. How many have 2 or more than 2 cars? 4%. This is for low income category. Okay, then again going back to the same data, how many people from the medium income category have 0 cars? 4%, 58% with 1 car, and 38% with 2 plus cars. Okay, and medium means more than 32 up to 48. Okay, and then you again do the same exercise with more than 48 as well. Okay, so each time you'll find out the total number of household which are in that income category, and then from that you will find out the percentage having 0 car, 1 car, and 2 or more cars. Okay, and then you multiply that percentage with the percentage of household for that income category multiplied by total. Okay, so for example, if I want to complete this matrix, let me go here. So have your calculators ready? So what I'm trying to find out is number of households which have low income 0 cars, low income 1 car, low income 2 plus 1 cars, and so on and so forth. Okay, and these percentages are from the first example. These percentages 54, 42 are from the first example. Okay, so I need 1, 2, 3, 4, and income. Okay, so for this one, total 60 households. Households having low income is 9%. Okay, multiply by households from low income which have 0 cars, 54%. Thirdly, come here, the only change will be here, which is 42 now. Okay, come here, the only change will be this. You do the same thing here as well. Medium income is 40%, and only 4% house have medium income and 1 car. It 38, the area has 51% high income households, and out of those, only 2% households have 0 cars. So this will be 2. Okay, 60 is total number of households, and the second number is the percentage of household in that area belonging to each income category coming from the census data, and the last number is what is coming from the previous sample. Percentage of households with that income category and that number of cars. Okay, so you can calculate these numbers. Okay, can you tell me these numbers? I already know this one is 14.
First one 2.43.
2. Okay. If you go row by row, I think it will be easier for you. Less things to change.
2 also.
2.
Two also.
Okay.
One. 9. 1. 9. 21.
As a check, the summation should be 60. Okay,
Doctor,
or 59, 61, something like this. Yeah.
Doctor, for low plus 2, I think it's 0.2, not 2.
0.2.
Because it's impossible to be 2.
60 into 0.09 into. No.
0.2, I guess.
Yeah, Doctor, 0.2.
What about the other?
The other
It's
are
almost 0. Right? The others are correct.
Yeah, I guess.
Okay, like I said, at the check, you can do the summation close to 60. We did some rounding off. Okay, close to 60, or you can write the exact values, leave the rounding off, keep the values as it is, and do the addition just to make sure that you are getting the correct number. Okay, the total should be 60, the number of households in the area. Okay, moving on. The next step is to find out the number of trips per household per day for each income category. Now, again, for each income category and each car household, the average number of trips are already calculated. Okay, the average number of trips for each income category and each household are already calculated. Okay, so for example, average, again coming from the sample data, let me go back. So this was the sample data. Again, we have 7 households. Like I said earlier, we have 7 households which belong to low income category, right? From those 7 households, you find out how many have 0 autos. Okay, so we have 1, 2, only 2. Okay, so for these two households, you find out the average trips per day. So this one has 2, this one has 4. So 2 plus 4 divided by 2, 3. Okay, so for each income category and car household combination, find out the average trips per household. Okay, so first of all, you find out how many households have low income and 0 cars. Find out their trips and take the average. So for example, low income and 0 cars, I can only see 2 So 2 plus 4 divided by 3, 2 plus 4 divided by 2, 3 trips per day. Okay, and so on and so forth. Okay, you will do the same thing for low income and one car as well. So I have one here. I have one here as well. This one. And this one. So 4. So for these 4 households, find out the average number. Okay, and so on and so forth. But this has already been done. This has already been done. We did it in the previous example and we plotted these graphs, okay, for number of trips per household for each income category and each number of cars. So for example, the average number for cars which have for households which have medium income and one car is 8. Okay, in the previous example they were showing the exact numbers, but here the numbers have already been rounded off. Okay, if somebody gives you the curve, okay, so for example, I did not give you the sample data, I just gave you this curve. The curve is plotted from the sample data. These curves are plotted from the sample data. So one curve for 0 autos, one for 1 auto, and the other one for 2 plus autos. Okay, so 0 autos with low income have only 1 trip on average. Okay, and with medium income they have 8 trips with 1 auto. Or let me go like this. So low income with 0 autos have 1 trip. Low income, medium income with 0 autos have 2 trips, and 0 autos and high income have whatever number. Okay, you get the number from the y-axis. Okay, and similarly with 1 auto, the number for number for low income, number for medium income, and number for high income. Okay, so if somebody gave you these curves, then you will just take the numbers for each point of intersection from the y-axis. These numbers will come here like they have done, or somebody gives you the data in the form of the table. So I already told you what to do. Okay, separate the number of households for each cell and then take the average. Okay, so for example, we have 0 autos, low income, only 1 trip per day, 1 auto, low income, 6 trips per day, and so on and so forth. Okay, they are taking the numbers from the graph. They are taking the numbers from the graph. That's why I said the numbers are already, rounded off. Okay, so but I showed you, if somebody gives you a table, it's very easy. Just select the households which for each category, take the average. Okay, now if you want to find out the number of trips for the entire area, this is the average for each category, and we have already found here. You already found how many households for each category I have. Okay, now let me take the graph, take the matrix from here. I'll paste it here so it's easier for calculation. Okay, I will make another table here now. Categories are same. Okay, so in this category, each household generates 1 trip per day. And for this category, how many households I have in the area? 2. So 2 into 1, which is basically 2, right? For this category, I have again 2 households, and each household out of these generates 6 trips. So 2 into 6 is 12. Okay, and as I said, if you want to be more exact, you can put the numbers with the fractions. Okay, I just rounded off for convenience. You don't have to round off. Okay, you don't have to round off. Okay, this one you said 0.2. Let me keep 0.2 so I get some numbers. So 0.2 into 7. Okay, how much is this?
1.4, doctor.
1.4. Okay, then 1 into this category generates 2 households or 2 trips per household, so 2 again. Then I have 14 and 8 trips per household. How much?
Doctor, 14 times 8, 120, I guess. Yeah, 120. No, not 120. 132.
132.
No, not 130. 112.
What are you doing, huh?
112. I'm calculating 8 by 4, 32. 112.
Nine into 13 is how much?
9 times 117.
Then we have 9 into 11. Then we have 21 into 15. How much?
I need a calculator.
1. Yeah, you need a calculator.
315.
1.
No, 315.
315. Okay, and if you want the total number of trips, just do the summation for all of them. Okay, so 2 plus 12 plus 1.4 and all of them. You add all of them. Okay, so what's the total number of trips?
$546.
46 trips per day. Okay, and that's it for the entire zone. Now this is for the entire zone. Now let me summarize what we have done up till now. Okay, because it was one example, it should have been completed in one lecture. We couldn't do it. First of all, they collected data from 20 households. Sample data. Okay, from the sample data, they found for each income category and car ownership, what percentage, in each income category, what is the percentage of car ownership distribution? So for low income, how many people have 0 cars? How many have 1 car? How many have 2 plus cars? Okay. Then same thing for medium, same thing for high. Okay. From the sample data. Then they plotted it. Then they found trips for each income category and car ownership category. Okay, for each combination of income and car ownership category, they found the average number of trips. Okay, so average number of trips for people having low income and 0 cars, low income and 1 car, low income and 2 plus cars, and same thing for medium and high income as well. Okay, again from the sample data from these 20 households. Then they collected additional data for I think we missed one step. Let me complete that, which is the percentage of the trips belonging to each the trips belonging to each what you call the trips belonging to each trip purpose. Okay, the trips belonging to each trip purpose. So what you have calculated is this. Okay, so what they have done is they have calculated the total for each okay, so if you take the total of this one, 2 plus 12 is 14, 15.4. Then what is the total for medium income? 2 plus 112 is 114 plus 117 is how much? 2 3. How much? 2, 3. How much is this? 2 plus 112 plus 117. How much is this? And then we have 231. And the last one is 315 plus 99 plus 3. 102 and 315.
417.
417. Right? Yeah. 417. Okay. The step which I missed was this one, which is the percentage of trips for each purpose. Okay. So again, we found it from the origin destination survey. An extra survey was done, origin destination, and in the origin destination survey they asked how many trips for each purpose for each income category. So for example, low income category, or the numbers are shown for medium income. For medium income category, how many trips were home to work? 17%. How many trips were non-home, so they did not start at home and they went somewhere else? 32%. And how many trips were from home to somewhere other than work? 51%. Okay, so if you come here, so this is the total. Okay, now from this total, I have to find out the trips for each purpose. Okay, so for example, if you are looking for medium income, the total for medium income is 231 trips. 231 trips. Out of these 231 trips, 17% belong to home-based work trips. Okay, so 0.17. This is medium income, home-based work. And then you have medium non-home-based. Again, 231 into 0.32. And you have medium income, and then you have home-based other. So 231 and 51%. I think we should have the percentages for the others as well. Should be, but it is not shown. Okay. How much is this?
This 139.3.
Again, you can do the rounding off, or you can just keep it as it is, no problem.
$74.
74. Okay.
Yeah. $117.7.
Okay. So this is for medium income. And then you do the same thing for low income as well. Okay. So this will change, and the percentages will be taken from here. Obviously, I don't know the scale of the graph, so I cannot tell you the exact percentage, but for example, 15%, 30%, and the remaining, whatever you get, 15 and 30 will be 45. So this one is then will be 55%. Okay, and same thing for high income as well. Okay, high income, maybe this is 19%, this is, I don't know, 34%, and then whatever is remaining will be home-based other. Okay, so This was the last step of the previous exercise from the for the sample data. So you collect another sample, origin, destination. You ask people from where did their trip start and where did their trip end and what was their income category. Okay, so if their trip started from home, ended at work, and they were in low income category, you will plot them here. Okay, and if they were medium income, you'll plot them here. If they were high income, you'll plot them here, and then you join that as a curve, and then you get the percentages from the y-axis for each case. And then if their trip did not start from home, then you will plot them for this curve. If they were low income, the point is here. Medium income, the point is here. High income, the point is here. Okay, and then if their trip started from home, but it did not end at the workplace or the educational place, then you will draw the third curve using that data. Okay, so that data is not completely given. Okay, so I just try to explain what happens for the medium income because the values are already marked. Okay, so if you know the exact scale of the graph, you can take the other values from the intersection lines, and then you can just do the same thing for low income and high income groups as well. Okay, these numbers will change and the total will be taken from here. Total number of trips will be taken from here. Okay, so each time you take the total number from here and then you multiply with the percentages you will get from the graph. Okay, so from the 20 household data set, we found the percentage of people belonging to each income category and car household, and we found the average number of trips for each income category and cars in the household. And then from the entire data, we found the average income, the total number of households. Then we found the percentage, the number of households belonging to each income category and car ownership. Then we multiplied that number with the average number of trips for that combination. And then we took the total number for each income category and multiplied by the percentage of trip purposes given from the origin destination data. Okay, so this is the entire process. Again, if you go to the book, if you go through it, you will see both the examples and you will see the explanation as well. So in case if you have any question, please go ahead. Okay, please go ahead, ask now. But if you want to revise later on, you will see in the book the complete explanation is also given. Okay, so any question? Okay, what we have done in the previous,
keep going.
Yeah, what we have done in the previous example, they have done it in USA for many zones, for many traffic analysis zones. They have done the exact same thing. Okay, they have done the exact same procedure, and they have found the number of trips on the basis of the size of the zone. Okay, and this exercise was done by ITE, Institute of Transportation Engineers. Okay, so Institute of Transportation Engineers did the exercise which I have shown you, or which we have gone through in the previous two examples. They collected the sample data, found the number of trips, the average number of trips, and the type of trips for each household. They did all these things. Okay, and they did it for multiple zones. So for example, they had, this one is for residential, single detached housing residential area. Okay, single detached meaning villas basically. Okay, single detached meaning villas, single family detached meaning villas. Okay, and then we have apartments and so on. So for example, they found 350 zones having single family detached housing, 350. Okay, in these 350 zones, they collected data on Wednesday. Okay, and in these 350 zones, the average number of households was 127 or 197. Okay, in some it was more, in some it was less. Okay, so on the basis of the whole data, so they had 350 values. 350 values. For these 350 values, they calculated the range and the average and the standard deviation. Okay, so for example, how many trips we found? 546 for one zone. 546 in one zone. So if I give you 350 values like this, then for these 350 values, you can find the average and the range and the standard deviation, which they did. Okay, so they repeated the same exercise which I have showed you in the previous two examples for all the single family detached housing zones. So zones should be similar. If you are calculating average, a standard deviation, or range, they should be for similar zones. Okay, so you cannot mix a single family detached housing area with an industrial area. Okay, so all this exercise is done for same type of area. Okay, and the values are plotted here according to number of units and the number of trips, average number of trips. Okay, so the data is plotted and the average and the range and the standard deviation is shown here. Okay, now so for example, you are a guy who is working in an area which is in USA. Okay, or you are a guy who is working somewhere else and you don't have the time to collect your own data. In both cases, you go to the ITE tables. So I'm just showing you a sample sheet from the ITE manual. They have hundreds of sheets like this for different types of zones. So in any case, when you don't have the data or you are working in USA, in that case, you go to ITE manual, the latest one. So they have different editions. Okay, you go to the latest one and you find the type of area from that manual related to your study, and then you find the average number of trips per household from that manual. Okay, so you found, for example, 546 trips for 60 households. So if you divide this number by 60, it will give you the number of households per unit, number of households per household, number of trips per household unit. Okay, 546 total number of trips divided by 60 will give you the total number of the average number of trips per household. So they did it for 350 households. So this is the average number of trips per household for 350 zones. Okay, so you can take this value and multiply with the number of households in your area. You will get total number of trips generated from your area. Simple. Okay, but keep in mind, you cannot do it every time. It will not apply to you it will not apply to your area every time. Okay, it's not, life is not that simple. Okay, using the data, so they plotted the data, number of units and the number of trips. Okay, and they have developed an equation as well. Okay, this is the equation for this graph. The graph between number of trips, average number of vehicle trips, and the number of households you have. Okay, so you can either use the average number or you can use the equation. Okay, whichever. In some graphs, the equation is not available because the data was very small. So for equation development, you need a lot of data. Okay, so if the equation is not given, you can simply use the average, multiply by the number of units in your area, and you will get the total number of trips. Okay, but as I said earlier, this is to be applied when you don't have your own data. Okay, or you are working in USA itself, the country from which this data is coming. Otherwise, I've already showed you the procedure what you should be doing. Okay, this is one way of calculating the number of trips generated from each area. Another way of doing it is rates based on activity units. Okay, so we have been saying that trips are generated because of activities, and your activities can be work, shopping, visiting friends, or medical trips, or many other things. Okay, so trips which are generated from the households are referred to as trips produced from the households. Trips which are produced from the households. Okay, and then you can calculate trips on the basis of the type of activity happening in the area. The type of activity happening in the area. For example, if your area is commercial, okay, then you can measure the activity in the form of the space which is allocated for commercial activities. For example, space, floor space, which is allocated for commercial activities in the area. So bigger the space for commercial activities, it will produce more trips. Okay, or your area is, for example, a business area. Your area is a business district, so it has a lot of offices. Okay, so in that case, the activity can be measured in terms of number of employees. So if more employees are working in your area, higher the number of trips produced from your area. Okay, so here, this is another method of trip generation, finding out trip generation. And in this method, we are just focusing on the activity. In the previous method, we were focusing on the area characteristics and the socio-economic characteristics of the people, income and households and so on. Here, we are just focusing on the activities. Okay, so from a particular area, they found the number of trips, the rate of trip generation is equal to this. Again, this is a from a sample. This is just a sample. Okay, you can develop your own rates for different activities. So if your area is a household, okay, you have households in your area, then home-based trips will be nothing. Okay, home to work trips will be nothing. Home-based other trips, the rate is 1, and non-home based trips, the rate is 1. These are all rates. Okay, rates. The trips attracted towards your area. Trips attracted towards your area per unit. Okay, so this is per household. So how many trips will be attracted towards your area per household? For home-based work, nothing. For home-based other, 1. For non-home-based, 1. Okay. Then again, if you have a non-retail employees in your area, if your activity that is happening in your area involves non-retail employees. Non-retail employees are basically office employees. Okay. So if you have office area, office buildings in your area, then the trips, home-based trips attracted towards your area will be 1.7 per employee, and home-based other will be 2 per employee, and non-home-based will be 1 per employee. Okay, similarly, so on and so forth. Okay, now the basic difference between this method and the previous method, the trips which you calculated from the previous method or from the IT manual, they are known as trip productions. So they are coming out of home, out of their homes. And the trips which are calculated using activity units, they are called as trip attractions. Okay, so you have trip production and you have trip attraction. For trip production, we consider the household characteristics, income, cars, and so on. For attractions, we consider the activity in the area. Okay, so this is given. So let us do one small example. Commercial center downtown contains several retail establishments and light industries. Okay, employed at the center 220 retail and 650 non-retail. So non-retail are working in the industries. Okay, and these 220 are working in the retail shops. Cold stores are retail shops. Malls are retail shops. So these things. Find out the trips attracted per day to this zone. Okay, so let us go here. This is in downtown. Okay, this is in downtown. So I have for retail employee, I have 2 rates, one for downtown and one for other areas. So I will use one which is given for downtown, and for non-retail I will use these trips. Okay, so what did they ask me? Determine the total number of trips. Okay, total number of trips. Okay, so let us start with home-based work. Okay, so the rate is 1.7 for non-retail. 1.7. How many employees of non-retail I have? 650. Okay, and for downtown retail, the rate is 1.7, and I have 200 employees for retail. Okay, so give me the number for this, and then we have home-based other. The rate is 2 and 5, so 2 into 650, 5 into 200. I have non-home based. The rate is 1 into 650 plus 3 into 200. This one is 650 plus 600 is 1250. How much is this? The first one? Tell me. 1.7 to 650 plus 1.7 to 200. How much? Are you guys here or not?
It will be 1445.
Okay. And this one should be what? Should be what? $23.50, I think. Okay, so you just use the units from the rates from the table, whatever table is given, and just multiply with the number of units which are specific for your activity. Okay. The activity is household, then these are the rates per household, but these are all trips attracted towards your household. Okay, trips attracted towards your area. Okay. Now, usually or ideally, number of trips produced and number of trips attracted should be equal. Okay, whoever is coming to the area will go back to his house, or whoever is going from the house, from the area, should come back to his house. Okay, so number of trips produced and number of trips attracted should be equal. Okay, but number of trips produced calculated from some other data set using some other method, and number of trips attracted calculated from some other data set. Okay, so you may see some variation between them. The number of trips produced may not be equal to number of trips attracted. So then we need to apply some balancing. Okay. So for example, so usually the trips which are produced are considered to be safer. Okay, they are considered to be more accurate. Okay, so these estimates, so for example, you have two estimates. Okay, so the estimate which you have for trips produced is considered to be more accurate than the estimate which is produced for number of trips attracted. Okay, so for example, you had the data for 3. I'm talking about the total number of trips. Okay, not for each zone. For each zone, you cannot, even if you try to make them equal, you will get into a lot of mess. Okay, so the total number of trips produced should be equal to total number of trips attracted for the entire study area, not for each zone. Okay, not for each zone. So this is why I said whoever is going from the house, he is going somewhere. So he is produced He is part of trip produced in one zone and he is part of trip attracted in some other zone. Okay, and vice versa. Okay, so anybody who is a part of trip attracted in one zone should be part of trip produced in some other zone. So total number of trips produced and total number of trips attracted should be equal. Okay, now you can see here that the trips produced is this much and the total number is 600. Total number is 600 and the trips attracted is calculated this much and the total number is 800. And again, we are talking about trips of a specific purpose. So you cannot, again, this exercise should be done for each trip purpose. So when you are balancing, we call this balancing. Making trip production and attraction equal is known as balancing. So balancing must be applied for the same type of trips, for the same type of trips. So you cannot merge home-based work trip and home-based other trips and try to balance them. It will be wrong. Okay, same types of trips can be balanced. So you, for example, you have trip production. Like I said, trip productions are considered to be safer. Okay, trip productions are considered to be safer. Okay, so or more accurate because they depend upon the household characteristic and the census data. So this will be considered more accurate, and we will try to change trip attracted. We will try to change trips attracted. Okay, so how to do that? We will take the ratio of trips produced upon trips attracted. Okay, and then you will multiply that factor with the number of trips attracted. For example, if I take this one, let me take it here. I have the zone here. 3. I have the trips produced. Okay, let me make another column here. Trips attracted. Okay, so trips produced, zone 1, 100. Okay, trips attracted without balancing, 240. Okay, 240. Then 240, so the factor will be 100 upon 240. And the new trips attracted, the balanced trip attracted will be 240 into 100 by 240. Okay, and this should give you one. I have shown it here. Okay, same thing will be done for this zone as well. So this is 200 and then the attracted is 400. Okay, so 200 divided by 400 and then you will multiply 400 by this factor. The number is given here, 400. That's 300, 160. So 300 upon 160. Okay, and then 300 multiplied by 300 and 160, and you get the balance number, which is 120. Okay, so now if you do the total, so this total is 600, we already know that. You do the total for this one now, the balance trips, 180 plus 120 will be 300 plus 300. So this is also 600. This is also now 600. Okay, so this is how you do the balancing. You have the trips produced and you have the trips attracted. The total must be equal for all the areas. How do you make them equal? You take the ratio of produced upon attracted, and then you multiply with the attracted number of trips or the calculated number of attractions, and you get the balance number. Okay, and in the end you can see that whether you have got the total correct or not. Okay, this is for trips which are home based, either home based work or home based others. Okay, this is a procedure, and you will stop here. This is a procedure for home based work and home based other trips. Okay, but if you have non-home based trips, then you have to do an extra step. What is the extra step for non-home based trips? Because for non-home based trips, they did not the place from where the trip was produced is usually the home, right? The place from which the trip is produced is the home. But in your zone, the home was not located. You are using income characteristics and household characteristics to calculate non-home based trips. So in that case, non-home based trips are more accurately calculated using trip attractions, the activity rates. Okay, for home based trips produced are more accurate because we are using the home characteristics, the household characteristics. For non-home based trips, trip attractions are more accurate. Okay, trip attractions are more accurate. Okay, because it depends upon the type of activity and not the household characteristics. So trip attracted are more accurate. So what do we do after, for example, let's say you did the same thing, and instead of assuming, now we said these are all what? Home-based trips. Let's say somebody told me these are not home-based trips, these are non-home-based trips. Okay, in that case, what will happen? You will still make the same table, you will still calculate trips attracted, but after calculating these numbers, you will change trips produced. You will change trip produced to this number. Okay, so instead of 100, it will become 180. Let me write it here for non-home based trips. For non-home based trips, the extra step will be, the first step will remain the same. You do this. Okay, if it is non-home based, the next step will be that these numbers will change according to this trip attractions. Okay. Okay, so if you have home-based trips, balance them and that's it. Home-based work or home-based other, just do the balancing and stop. If you have non-home-based trips, do the balancing, then make production equal to the new attraction. Keep in mind, the first step has to be done. The balancing has to be done in both cases, home-based or non-home-based. For non-home-based, after you do the balancing, then you make production equal to attraction after the balancing, not before the balancing. Okay, so balancing is required in both cases. Balancing is required in both cases. Okay, because without balancing, the total number will not become equal. So balancing is required in both cases, but for non-home based, you have to play with the trips produced as well. Okay, and the reason I told you, I will rephrase it, that for non-home based trips, attractions are more accurate because non-home based trips do not depend upon the household characteristics. Trip produced were calculated using household characteristics, so they are less accurate for calculating non-home based trips. Okay, so this is why we have done it. Okay, so after that we will start the trip distribution phase, and I will start it after the prayers. Okay, so let us have the 15 minutes break, and we will meet again after the prayers.